In this video, we will be discussing the new enhancements in ETABS version 23.0.0. Here are the new enhancements. For data exchange, ETABS now allows floor imports directly from SAFE, creating new ETABS models, warping and buckling analysis of steel beams using open section. For loading, we've added the Hong Kong 2019 auto wind code as well as the Mexican auto seismic load case. For design, we've included general shell design, including multiple codes for concrete slab design, shear wall design, as well as concrete frame design. Okay, let's get started. This is the SAFE model that we'll be importing into ETABS. So let's open up ETABS. To initiate the import of a SAFE model, we'll select the File menu, Import SAFE FDB file. This command allows users to import a SAFE model into an existing ETABS model at a predefined story level. So the SAFE model should be from version 22.0.0 or later. So an important note, the two models should be in the same units. It's recommended that the ETABS model be saved before this operation, as it cannot be undone. So you have the ability to select the story level where the SAFE model will be imported into, entering the global coordinate offsets and orientation plan. Now let's take a look at some of the import options. So in this form, the import options allow users to control what is to be imported and what to do with conflicts of names of properties and duplication of locations of structural objects and loads. For instance, if a particular property type is selected to be imported, all properties of that type in the SAFE model will be imported. Any name conflict with the properties in ETABS model are handled based on the option chosen for that property type, ignore incoming, or overwrite. So if a particular property type is selected not to import, the properties assigned to the SAFE model, structural objects, will still be imported if not found in the ETABS model. Another important note, columns and walls above the story level and below the bottom of the ETABS model will not be imported. Also, any restraints or springs at the bottom of columns and walls that do not end up at the bottom of the ETABS model will not be imported. Also, any design or detailing associated with the slabs, beams, or design strips are not imported as well. You also have the ability to import specific loads, load patterns, as well as grid systems. So after the import, a new group will be created for all objects added by this imported SAFE model, so users can quickly identify and select the members that have been imported. It's recommended that the imported items be checked and, if necessary, modified before the replicate story command in ETABS is used to populate the other stories. Now we click OK, and here is the SAFE model that has been successfully imported directly into ETABS. Next, let's take a look at the buckling FEM plugin. As you can see, I've selected 6 frame elements. These steel frame elements imported from ETABS are automatically converted into detailed shell models by discretizing their cross-section. This discretization enables the program to capture both global and buckling modes that cannot be represented by traditional line element models. So these members are imported directly from the program, including their geometry and section properties. While end forces may also be imported to help define the stress state, the user must apply the appropriate supports and ensure that the load cases are consistent with the intended buckling scenario. So to enable the FEM plugin, we'll go under Tools, so as you can see, the interface is organized into 4 main areas. At the top, a tabbed ribbon provides access to the available modeling and analysis tools. Each button in the ribbon typically opens a dedicated form or dialog with corresponding settings and controls to edit the model. You can see here on the left-hand side, the Model Explored displays a tree view of all imported data, including members, materials, and sections. Once a steel member is selected, you'll see on the right the Property Explorer shows a table of properties for the currently selected item and also allows certain properties to be edited directly. Let's make a few updates before running the analysis. If I click on End Restraints, I have the ability to select columns, beams, or all elements. We'll select the columns and apply some end restraints. Next, let's add a uniform load to all the steel beams. Some other options that are available include mesh controls as well as member connectivity. There are two options here, first one being the rigid connection. By default, members that share a node are automatically connected through a rigid connection after import. A rigid connection is implemented as a joint constraint that ties all nodes located at the end of the member to a master node, which in turn connected to the shared node by means of a rigid link. Another option is the weld constrained connections. These are for members that do not share a node, or in other special cases, a weld constrained connection can be used. This is often useful for girders framing into main beams that are joined through automatic meshing rather than a common node, or when the user wishes to simulate a more realistic connectivity scenario. Now, under linear analysis, we can simply click Run Analysis. Now we can take a look at some output. Under Display Controls, you have the ability to select the case, step number, as well as the type of output you wish to view. You also have the ability to toggle transparency, toggle the extrusion, as well as toggle mesh visibility. If we go back to modeling, now let's take a look at the buckling modes analysis. You can select the number of modes you wish to run, then simply click Run Analysis. Again, under Display Controls, you can select the case as well as the mode number you wish to view. You can simply step through them using these arrow buttons. And putting the cursor over the steel beams gives you the exact magnitude at that specific location. Now, this is a general overview of the Buckling FEM plugin. We'll be creating a video going from beginning to end, going through all the specific details and output in the near future. Please visit our website for more information.